அனைவருக்கும் வணக்கம். யாவரும் கேலி திருநுல சங்கம் பெருமையுடன் நடத்தக்கூடிய நிற்க அதற்கு தக வாரம் 17. நீங்கள் அறிந்ததை மற்றவருக்கும் கற்பித்தால் நீங்களும் ஆசானே. மாணவர்களே, ஆசிரியர்களாய் வாரந்தோறும் சனிக்கிழமை மாலை 6 மணிக்கு வைகே தளம் நேரலையில் காண தவறாதீர்கள். இன்று நம்மளோட கலந்திருக்காங்க அனுப்பிரியா அவர்கள். எதை பத்தி சொல்லித்தர வந்திருக்காங்கன்னு பாத்தீங்கன்னா, பர்த் ஆஃப் ஸ்டார்ஸ். யாவரும் கேலி திருமண சங்கத்தின் சார்பாக அனுப்பிரியாவிற்கு வாழ்த்துக்களும் பாராட்டுகளும்.
Thank you, ma'am. Good afternoon to everyone. This is K. Anupriya, studying 3rd BSc Physics in Mother Kesari Jain College for Women, Vaniambadi. Now, my topic is about birth of stars. First of all, what is star? Now, we are going to see about what is a star. A star is a giant luminous ball of superheated gas, which means a luminous gas is a brightness star which is massive in the all over space which is presented in the solar system. Just like our star, the sun, we are thinking about the sun as a planet. Not the sun is a planet, it is also a star. They are scattered through all the space so far away. They are scattered through means the light from the sun is scattered through all over the space. It will scatter the light to all the surroundings and environment of our space present in the earth. So the light will get all from the stars. Then it would know 100,000 years to reach them. By the scattering of the stars, we will reach the sunlight from the thousands of each time. How the stars are born? They begin in clouds of dust and gas very far away. Actually, the stars is formed by the combination of the dust and the many gas particles together. Gravity gathers the hydrogen gases and the other particles of the dust, and clouds grow many denses. Due to the gravity forces, hydrogen gas and the other particles of the dust and the clouds are just combine together to form a star with the dense mass. So then as it sequences, it tighter, the hydrogen heats up with a fantastic 8 million degree Fahrenheit. In Fahrenheit, its heat temperature is about 8 million degree Fahrenheit. Likewise, in a Celsius, and 10 million degrees Celsius. Nuclear fusion turns the hydrogen into helium and the fire ignites. Due to the process of nuclear fusion, the hydrogen fuel is just converted into the helium while it gets heat up. The nuclear fusion is the nothing but the core of the sun hydrogen is being converted to the helium. Every planet and every star has such a core. The core is a part of the element and the sun star for everything. In that, the hydrogen and the helium is present like a fuel. That fuel is act as some primary source for the reaction of nuclear fusion, so that hydrogen is changed into the helium. Then it takes 4 hydrogen to fuse into each helium. Sun has a different layers with the different particles. Every planet and every stars have the different layers with the different colors and the different elements. These layers are composed of that core materials with that core different particles. It have composed of different layers. It consists of 75% of the hydrogen and 25% of the helium with its mass. What colors are stars? Now we are going to see about the colors of the star. The colors of the stars depends upon the how hot they are. The colors of the color of the star we can determine by their temperature only. Depends upon the temperature only, the stars will variation in their colors. The temperature varies along a band on the graph is called as the main sequences. The color of the stars from hard and bright blue, and when it is cool, dim red. When the star is in too much temperature, it becomes the color dark blue. When it comes in the very low temperature, it looks like dim red. What is the biggest star? The biggest star are the supergiants. Actually, the stars are the most biggest one. While seeing in the naked eye from the surface, it looks very small because the stars are presented far away from the Earth. That's why it looks very small for us in the surface. The biggest star are the supergiant stars. Antares is the 700 times as big as the sun. Actually, we are thinking that the sun is most biggest one, but than the sun, many of the stars is present, which is more bigger and brighter than the sun. Likewise, Antares is also a star type of a star, which is 700 times bigger than the sun, which glows brightly in the night sky. The largest star we know that is VY Canis Majoris. VY Canis Majoris is the most largest one in the solar system. We could probably fit a sun inside VY Canis Majoris 2100 times, which means we are thinking that the sun is most big, right? We can fit a sun inside of his VY Canis, which means most bigger than that of sun. So we can fit inside the and VY Canis. What makes the star glow? They glow because the enormous pressure deep inside that generates nuclear fusion reaction. Why the star gets glow? How the star gets glow means inside that star, enormous pressure, the deep and enormous pressure is takes places. That's why that star gets glows in the night time. What makes the stars twinkle? Stars twinkle because the Earth's atmosphere is never still. Sunlight, starlight twinkle has the hair waves. Because of the scattering of the hair waves, it gets twinkles in the night sky. How many stars are there? It is hard to find because n numbers of stars are present and n numbers of stars are producing day by day. Not by day, it is producing to produce the time is billions and millions of years for the production of each star. Now we are going to see about the life cycle of the stars. How the life cycles takes places to produce a star. We will see the birth of a star. In order for a star to go through the process of nuclear fusion, already we say that nuclear fusion is the process that takes place. The particles get fused together. In order to that, the core of the sun, in that the fusor takes places, hydrogen is converted into the helium particles. So it is called as a nuclear fusion. It takes place that the 4 hydrogen atom is needs to fuse with the only one helium. It's called as a nuclear fusion reaction. These fuels are mostly the nuclear fusion takes place by the nuclear fusion takes places by the process of hydrogen and the helium, also combined of discrete amount. Discrete amount means very small amount. Discrete amount means very small amount of elements is taken for the nuclear fusion. While a star is using up one type of a fuel, it must change its size. If any one of the star is taking any one fuel for the process of nuclear fusion, it gets reduced in its size and its pressure. So that's why they need to use all the elements for the nuclear reaction. Making this changes is a very gradual process which usually happens over the course of millions to billions of years ago. This process or happens in the course of millions to billions of years. The star is born in an immense cloud of gas and dust known as a nebula. Actually, the star is formed by the many dust, gases, and the clouds particles. So likewise, the compressed and the most dense cloud of a gases and the dust particles are combined to form a nebula, like a star. Now we are going to say about nebula. The word nebula in Latin means cloud, which is perfectly suited for that what it is. The name is perfectly suited. A nebula is a cosmic cloud of dust and the gas that floating in the space. We already said that the star is a combination of gas and the clouds particles which is presented in this space. Likewise, the nebula is also a combination of a cosmic clouds, dust and the gas floating in the space. All the elements needed for a star are stored within the nebula. What are the elements is needed for the fusion reaction? So that elements are stored in within the star itself. Helium and the small amount of gases, oxygen, carbon, nitrogen, which are called as the heavier elements. And the hydrogen and the helium, and for the process of nuclear fusion, the elements like hydrogen and the helium are taken in the more amount, and the oxygen, nitrogen, and the carbons are the heavier elements, which is compared to that of the hydrogen and helium. While comparing with the hydrogen and helium, oxygen, carbon, nitrogen is an heavier element. That's why we are taking that elements in this very small amount when comparing to that of the hydrogen and helium for the process of nuclear fusion. About 10% of helium is taken and 90% of hydrogen is taken in the nebula. About 0.1% only we are taking that carbon, oxygen and nitrogen because of the heavier elements. Because these elements are heavier elements, so we are taking about 0.1% only. There are also 5 different types of nebula. Not only nebula is an only one type, it is the 5 types. In that, there are also a 5 types: emission nebula, reflection nebula, dark nebula, planetary nebula, and supernova nebula. By the way, planetary nebula have nothing to do with planets. Nebula to stars. How the nebula is converted into the stars. In order for the newborn star to go from a nebula to a star, actually the nebula is the first and foremost layer and the most young star like that process. It is the first star to grow up a new big stars. It must reach a critical mass of approximately 80 times Jupiter's, but also its mass is about 80 times greater than that of the Jupiter. Once this occurs, the internal pressures raises the core temperature high enough to begin nuclear fusion. The internal pressure and the temperature leads the star to begin the nuclear fusion to expand its size. Dust, gas, and other materials gradually wait in the nebula for any gravitational disturbance to pass through the nebula. Once this happens, it causes ripples and a process called accretion. Once it gets ripples, this process is called as accretion. Accretion is growth in the size or extent. Accretion is a growth or extent. Accretion is growth the size of extent. This means the star grows larger. Due to the process of nuclear fusion in the core of the nebula, it gets expanded in its original position. It will grow. Star to red giant. As a few billion years passes, a star runs out of its protons. After a few billion years ago, the star will get out of its protons. The result is a core left within the alphas. In that result, they left with the alpha also. Even though the outer layer still contains the hydrogen, after that emissions of or that run out of protons and the alpha, the hydrogen fuels is present in the outer layer. They aren't hot enough to fuse. They are present, just they are present, but they are not much hot than the first stage. It is little hot. Without the fuel, the star begins to cool and contract. So they are in the little temperature, right? That's why it becomes compressed. Compressed means from its original size, it reduces its size because of the insufficient temperature of the hydrogen fuel in the core. The outer layers sink into the core due to the gravity. Due to the gravity, the outer layer shrinks. The star now has a source of energy. After the source of energy, the core is now hotter than it is during its normal life. Then, by the source of energy, it gains um, fuels and takes places to the normal life. By the time the radiation reaches the surface of the star, that when it comes to the normal position, normal life, then it starts its work process side by side daily. Its nuclear fusion will take place whenever the fuel will get enough much energy, it will take places. When the radiation makes the star red, as the star grows huge, weak radiations, we already see that when the temperature gets low, it looks like a diminish red. Likewise, weak radiation makes the star red color. As the star grows huge, I think it obvious they were get the name from when the temperature of the sun is get reduces, the colors will changes from the beginning. When it is dark, it looks like a bright bluish color. When the temperature of the star is reduces, it looks like a diminish red giant. Red giant are the very brightest one in the space. Red giant stars are the not very hot. Actually, red giant is the biggest one, not the brightest one. Not a hot, not much temperature it doesn't get, because its colors is very much red, right? So the temperature is very much less. Red giants literally blow up like a balloon because the all the helium get possesses. It looks like a balloon like a structure. The size of the red giant can be 10 to 100 times the diameter of our sun. The size of the red giant is about a diameter of our Earth about 10 to 100 times. Red giants of formerly large stars are sometimes called as a supergiant stars. Most biggest stars are also called as a supergiant stars. That that size is thousands times greater than that of the sun. They have the luminosity often 10 lakh times greater than that of a sun. சன்னை விட அதோடைய luminous, அதோடைய brightness வந்து 10 lakhs times greater-ஆ இருக்கு அப்படின்னு சொல்றாங்க. எதுக்கு அப்படின்னா சூப்பர் ஜெயின்ட் ஸ்டார்ஸ்க்கு. Next, red giant to white dwarf. Once a small red giant runs out of your fuel, it begins to cool down and contract due to the gravity. Once a small red giant stars is lost the fuel, that begins to cool down. When the fuel is lost, it the temperature will get down and it become cool, and it get contract. Contract means it reduces the size from its original due to the gravity. Due to the gravitational force, the size will reduces because the temperature is get reduces. The inner parts of the star contract, which gives off heat and causes the outer planets to expand. அந்த ஸ்டார்ஸ்ல இருக்கிற இன்னர் பார்ட்ஸ் எல்லாமே வந்துட்டு ஹீட் ப்ரொடியூஸ் பண்ணி அந்த அவுட்டர் பார்ட்ஸை வந்து எக்ஸ்பேண்ட் பண்றதுக்கு ஹெல்ப் பண்ணுது. The expansion of our parts causes them to slowly separate and form a planetary nebula. After the explosion of a outer parts, after the process, it will explode. So that explosion will cause that a planetary nebula. The inner parts of the star continue to contract until it reaches the size of the Earth. The inner parts of the star will continue to contract when the size of the Earth they reaches the size of the Earth until it get contract. Electrons being overlapped due to the atoms being crushed together. Due to the crushing of electrons, due to the crushing of an atoms, the electrons get overlapped. So that it can be contracted. Electrons being overlapped due to the atoms can be crushed together. Since the two electrons cannot be controlled, take up by the same spaces. Actually, the binary, they form the small sphere of a matter is called, after the explosion of these particles, they forms the white dwarf like a star. White dwarf. A white dwarf is a very small hot star. A white dwarf is also a star. It is very much small, hot star, and it is the last stages of the fire life cycle of a star. Life cycle oda last stage பாத்தீங்கன்னா white dwarf. அது வந்து small இருக்கும், and then hot star. Temperature is much greater than of all. The last stage of the life cycle for the star, such as our sun, like our sun. White dwarf have similar masses to our sun, except a white dwarf is about 1% of its sun's diameter. The size of its white dwarf is about 1% of a sun's diameter. Approximately, a white dwarf is the size of Earth. White dwarf have a surface temperature of about 8,000 degrees Celsius or more. But being small and hot causes the white dwarf has a bright luminosity. The temperature of the white dwarf is about 8,000 degrees Celsius, but its luminosity is bright. White dwarf have the luminosity of 1% of our sun's luminosity. Its diameter also 1% of luminosity, and its luminosity also is 1% of sun's luminosity. Then red giant to supernova. Most small red giants die as white dwarf, but the massive red giants die in a more spectacular way. Most of the small red giant stars are get die as the white dwarf. Most of the biggest stars வந்து white dwarf change ஆயிட்டு அது வந்து டெத் ஆயிடுதுன்னு சொல்றாங்க. But the massive red giants die in the more spectacular way. It after the explosion it goes into pieces. That is a spectacular way. A supernova. After the fuel in a red giant is exhausted. Exhausted is nothing but finish up. Completely it is finished up. Exhausted means after the fuel in a red giant is exhausted, the core becomes cooler. After it is finishing up, the core of that planet or the star, it get cool. The core becomes cooler and the internal pressure begins to decrease. When it becomes cooler, the internal pressure of the planet becomes decreases. The planet becomes decreases. Internal pressure also get decreases. That causes the planet contraction. This is the distress event which leads the collapsing of the star. The outer layer starts to gain. How they have the fall. The outer layer starts to gain. The outer layers start to gain heat as they fall. This heat ignites nuclear fusion in the outer layer, which causes them to explode. All these processes they make them explode. This is also called as a this explosion is called as a supernova. For a few days, this explosion is brighter than the whole galaxy. For a few days only, this explosion will glow very brighter than the whole galaxy. Supernova. Next, we are going to see about supernova. Supernova is an explosive death of massive star. At, at its height, a supernova can be bright as 100 million bright stars. A supernova is a bright of 100 million bright stars. Supernova have been accounted for creating a heavier elements than the hydrogen and the helium. Over the years, two types of supernova have been founded. A supernova which happens in a binary star. Binary star is nothing but an orbit at two type of stars is present. That is called as a binary star system. It occurs by the gases from one star that is falling into a white dwarf is then it will get exploded. A supernova which occurs when a homogeneous star. A supernova homogeneous means very huge, which is biggest one, at least 10 times more massive than that of our star. Then it explodes because of the malfunctioning means insufficiency of the fuel for the process of nuclear fusion. It gets exploded. Next, supernova to neutron stars. After the spectacular explosion of a supernova, outer layers are blasted into the space and form a nebula. After them explode, that supernova will get exploded. Then the outer layer of them are blasted into the space all over the space and form a nebula. The core is shrunk by the gravity and condensed into the sphere shape approximately. The electromagnetic forces keep the electrons out of the nucleus. Due to the electromagnetic forces, electrons are kept out of the nucleus. Electromotive force is the only thing that the matters the stars would be able to string such a size simply because the mass and the number of atoms. However, because the star's mass, gravity will defeat the electromotive forces. Since the electromotive force is now broken the protons and the electrons to combine to make the neutrons. All, the, all that is left neutrons and the neutron stars is formed here. A neutron star is formed when a massive stars get collapses or in the case of explode. That is seen in the pictures. Next, supernova to the black hole. As we just learned that a neutron star is made from a supernova explosion. A neutron star is formed by the explosion of a supernova in the space. Also, a neutron stars can create a black holes. If the neutron star becomes too big, the gravitational force becomes too much for the pressure. When the neutron stars become the big, then the gravitational force also become high and the pressure also get high and it cannot collapse. The neutron stars continue to shrink until finally it becomes a black hole. Then the neutron star get continuously shrink when it is finally become a black hole. The black hole it will shrink. Next, black holes. Little is known as the black holes. Much little one is also known as the black hole. Not even the density of the information that we do know about them. Black holes are the remnants of most massive stars in the universe. Black holes is seen very small, but its weight is about much more dense than all because the most massive stars in the universe. The gravitational, because of the gravitational pull of the black hole is so great, so that nothing can escape from it, not even light. So, so it cannot escape a light also. Therefore, they are black holes. Holes are believed to distort the space around them, also suck in surrounding objects. These are the black holes images and the types of, now we are going to say about the types of black holes. Miniature black holes. These type of black holes have event horizon as small as atomic particles. Physicists suggested that they have created during a Big Bang theory. Many astronomers and physicists are identified that these are produced by the theory of Big Bang theory. Miniature black holes were created more than 10 million years ago, and they are compressed into really small point. They are compressed into the small point. Uh, Fast moving gases, jets, and the gravitational force are equal to 10 billion suns compressed together. They are what we call as a supermassive black holes. These are called as the supernovas, black holes. Their event's horizon is the imaginary sphere around them, which nothing can escape. When a matter is entered the black hole, it increases its size. When a matter or enters the black hole, the size of it will get increases, and reaching the other matter will not absorb the before. Next, the birth of the solar system. How the solar system gets birth. Collapses and the interstellar spaces. Formation of the protostars. A disk condenses and the dissipates. In this is solar system அப்படின்னா என்னன்னு பார்க்கலாம். It is a gravitationally bounded system of the sun and the object that orbit it. Sun is the largest of the four gases and the ice giants and the four terrestrial planets that followed by unknown nuclear number of dwarf planets. These are the called as a solar system. What is mean by interstellar space? We can see that interstellar space or that star form in a cold, dense region of a space is called as a molecular clouds. Which star is formed in the cold region, dense region is called as a molecular clouds. When the force gravity is pulling in on the cloud is greater than that of the internal pressure pushing out, the cloud collapses into the protostar. Actually, the protostar is known as the young star that is still gathering mass from its parent molecular cloud, which is low mass. Thus, protostar is a very less mass. The disk condenses and dissipates, the third process. That dissipation is either by a photoevaporation or the plant formation, that including a grain growth in a broad sense. This is because the Jupiter is more important than the Earth. The birthplace of the star. The space between the star is not completely empty. Thin clouds of the hydrogen and the helium seeded with the dust. The combination of the hydrogen, helium, gas particles and the clouds are combined to form a star from the dying stars in the interstellar spaces. Interstellar is nothing but the stars which are formed in the most cold region under the space. A little bit of a spin goes along. Galactic shear and the turbulence give every core of a little spin. The spin of a galactic shear is given here and a lot smaller, but they get a lot smaller and the spin goes up. When it gets smaller, the spin goes up. It is the reason that we believe that many planetary system, it is a part and a parcel of the stars. The formation process make this formation will this process will make the disk like a process. Typically, galactic spin makes a disk about size of our solar system. Next, sword of origin. The sword of origin is it is a compact asterism in a constellation origin. The nearest great stellar nursery to us is the great origin molecular cloud, which is 1,000 light years away. And manufacturing the stars, 1,000 light years, the 1 light years is equal to 3 into 10 power plus 8. So it makes For the origin of Sword of Orion, it takes 1,000 light years away. It is probably how the typical star is made. And this is the star and the planet pictures, and it is n number of stars which present in the space. Then what is the sun? Sun is the star of the center of the solar system. It is a nearly perfect ball. This sun is a nearly a perfect ball of a hot plasma heated to the nuclear fusion reaction. The temperature of the sun is about 5,778 Kelvin. The age of the star sun is 4.603 billion years ago. So thank you for giving me the wonderful opportunity. Thank you, Vyavaram Keli Tiranvalar Sangam. Thank you for my management, principal ma'am, and HOD ma'am. Thank you all.
Thank you, man. Thank you for your presentation. Thank you so much.